Welcome back to the Reaper's Game Dev channel. Today I'm going to improve the Tron Light Cycle. Right now it's kind of choppy and there's some gap on the trail. This will be a devlog / tutorial since I will show you the process of fixing this issue in C++. As you can see, there's some choppiness in the trail and there's some gap between the meshes too. Here is another example. Here it's a little bit better since the mesh is aligned. There's a performance issue when the tail is longer. In the typical level, the tail should be way longer than this. With the current system, when there's a long tail, it causes performance issue and it needs to be fixed. So this is what I've done in the past week. The tail is now way smoother and there's no lag when there's a long tail. It was quite a challenge since the vehicle moves really fast, so I will describe how I achieve it with some designs and codes. And let me show you a jump. Let me get out of here, and as you can see, the trail is quite smooth and there's no gap in the air. So basically I've created some short tail that follows the vehicle around, and this one, like the vehicle is here, short tail is the red, will follow the vehicle at quite a high speed, so eventually short tail will follow along. But to prevent the choppiness, I just interpolate the position toward the vehicle position. So basically it won't go right there, it will move slowly toward the vehicle, and all the points on the short tail will move toward the vehicle. When it reaches a configurable length of the short tail, it will become the long tail. So this one won't interpolate with all the others, thus saving some time on the FPS and prevent recalculating and interpolating the position on every tick or so. So basically that's just what I've done. First I tried with the spline components, but afterward just decided to just keep in memory the position of the last known position of the vehicle. So the code is quite simple. After all that, on creation I just create the short tail, and on tick I do uncompute the velocity of the parent actor since it's a child actor attached to it, and if it goes greater than 100, that should be a field and not hard coded there, I interpolate the short tail mesh position. So basically I have an array of mesh and update its position to the actor location. Then I interpolate with the Gizmet library, vlerp, all the position with an interpolation speed. So basically it moves towards the vehicle slowly. Then I update the last position. If I go back to the tick, there's one issue that I got here was basically the tangent. If I don't recompute the tangent, it will always be up, so there will be gap when there's in a slope or a curve like this. If I recompute it, I can then compute the tangent of the points here. Basically we don't see the points, but this way it will be way smoother. So I've created a simple compute tangent function. So I compute the direction from A to B by doing position B minus position A, and the direction from B to C by doing the same thing, position C minus position B. Then I could compute the tangent by adding both directions divided by 2. So I have the tangent of point B. And recompute the tangent of the short tail. Eventually, after it reaches a certain amount, the length of the short tail, I just create a new spline mesh and attach to the last position of the short tail, so it can be attached to it. Not really attached, but will lerp to like I did for the short tail. So that was the progress that I've done to the Tron Light Cycle. I hope you like it. I've tried to do a YouTube video about for like a tutorial, but it wasn't my forte and took too much time to do it, and it wasn't good enough, so I just did a small recap of what I've done, and I think I will continue that way. In the next video I will talk about vehicle selection, abilities that I want to implement, and I will show you some prototype of them. And if you like this video, please subscribe and press the like button. Thank you. See you on the next one.